people always say, or in most of the books also it is mentioned, M is parallel mirror. If you see the crystallography, the 32 classes, there we have either M or we will have 1 by M. Okay, so in there people used to say M is parallel mirror, 1 by M is perpendicular mirror. It is not true. M is always perpendicular mirror. M is always perpendicular mirror. Okay, suppose I am saying, like here I have told 4 M and M. This 4 stands for C axis. That means each position is representing something. When we are giving the symbol 4 mm, 4 by m, 2 by m, 2 by m, or we are giving 2, 2, 2, or we are giving 4 by m, 3 bar 2 by m, any symbol what we are giving, that three different places, they represent three different items or three different elements. Like here this 4 is representing the vertical axis. This position of M is representing axial or crystallographic axis. This position is representing crystallographic axis, which is A1 and A2. The next position represents diagonal axis. For tetragonal system, this is the pattern. If you go to orthorhombic system, suppose 2, 2, 2. This is a class from orthorhombic system. This first position is always the longest axis, which is B axis. In case of orthorhombic system, B axis is the longest. So first position belongs to longest axis. Second position will become A, third position will become C. The first position is B, second one is A axis, third position is C axis. There we are having three different positions for three different axes because all the three axes are unequal. Whether it is orthorhombic or it is monoclinic or it is triclinic, will have unequal axis. Okay, so in orthorhombic we have this three position dedicated to one B axis, second one A axis, third one C axis. When we come to tetragonal, the first will become C, second one will become crystallographic axis, and the third one will become diagonal axis. When we will go to hexagonal system, for example, let's say 6 to 2 or something like that, then this 6 is the C axis, this 2 is crystallographic axis, means A1 equal to A2 equal to A3. These three axes are represented by this symbol, means the three axes are twofold. A1 is also twofold, A2 is also twofold, A3 is also twofold. The first position belongs to C axis, so C axis is sixfold. Always the first position belongs to the longest axis. Whichever system it is, the first position is always the longest axis. Okay, so apart from isometric, because in isometric everything is equal, so here it is six-fold symmetry for the C axis, then two-fold for the crystallographic axis. Three crystallographic axes are showing two-fold symmetry. The next position is for the diagonal axis. So the three diagonal axes in hexagonal system will have three crystallographic axes and will have three diagonal axes. So for the three diagonal axes, we will have two-fold symmetry. Okay. So now our question is whether M is parallel and 1 by M is perpendicular, whether this is true, or M means always perpendicular mirror, if this is true. So the second one, what I am saying, M means always perpendicular mirror. Like if you will go through this concept, M is parallel and 1 by M is perpendicular, then there will be two classes. Among the 32 classes, we'll have two classes which we will study as deviation. If you have studied it, or if you don't have, like if you have not studied yet, then we will study later. Now because I was explaining crystallographic axial mirror plane and diagonal mirror plane, that's why I am coming to this aspect. If you will know this M as parallel and 1 by M as perpendicular, then out of the 32 classes, there will be two classes which you will be studied as deviation. They will tell this is the deviation. But if we'll go through this concept, M means always perpendicular, then that is always true. There is no deviation. It is always true. M means always a perpendicular mirror. Okay, you remember this fact? So now if I am telling axial mirror, like I told just now, A1 equal to A2. So axial mirror means the class symbol what I have taken, 4m and m, 4mm, that is the symbol I have taken. The second m is axial mirror and third m is diagonal mirror. Now I have told you that m means always perpendicular, whether it is m or it is 1 by m. M means always perpendicular. Perpendicular to what? Perpendicular to the position. Like here, as I told, the second position is A1 and A2. So m means a mirror plane perpendicular to the crystallographic axis. The m in the second position represents mirror planes perpendicular to the crystallographic axis. That means one mirror will be perpendicular to A1, another mirror will be perpendicular to A2. Now because A1 and A2 both are perpendicular, so which mirror is perpendicular to A1? That is, I'll erase everything and here I'll write. M is perpendicular to A1, M is perpendicular to A2. Now, suppose this is the A1 front to back, this is the A2. The mirror which is perpendicular to A1, that coincides with A2. This is the mirror which is perpendicular to A1. Similarly, the mirror which is perpendicular to A2, this is coinciding with A1 because A1 and A2 are perpendicular. So this is the mirror perpendicular to A2, it coincides with A1. So for this reason, if you are taking M as parallel or perpendicular, it doesn't matter in tetragonal system or cubic system. If you go in tetragonal system and cubic system and also in orthorhombic system, there if you take M parallel or perpendicular, then there is no issue because which is perpendicular to A will be parallel to B, which is perpendicular to B will be parallel to A. But when you go to trigonal and hexagonal, there the horizontal axes are not perpendicular. But I told that two deviation, what people will teach you as deviation, those two classes will come under this trigonal and hexagonal because there if you take M as parallel and by M is the perpendicular, then there you will get wrong answers, you will get wrong outcomes. So in those cases, they will tell it is deviation. Okay. But if you go by this formula, M means always perpendicular, then you will get those classes correct. Means you will get the correct order of faces in those classes. In trigonal system and hexagonal system, for example, I'll tell the next example is from hexagonal system only. It is 6m and m, let's say like this. If it is 6m and m, or let's say another example, I'll take 6m2. This is one class, 6m2. So here the c axis is 6-fold. This is the position of A1, A2, A3. Just now, like before some time I told, the second position is for horizontal crystallographic axis and third position is for diagonal axis, edge diagonal axis. So here this M is not parallel to, if you know this class, you can see the image. Right now you can open your book and see the image. In case of 6M2, this M's, they are taking parallel to diagonal axis. This M is parallel to diagonal axis. In your book, if you can see, for this class, 6M2 class, you can see the mirror planes are parallel to diagonal axis. Why now this mirror plane is parallel to diagonal axis? If this is the place of crystallographic axis, why this M is parallel to diagonal axis? This they will tell it is the deviation. But here the reality is M is perpendicular to the position. Mirror M means whenever it is M, whether it is M or 1 by M, it is always perpendicular. That means here the crystallographic axis are having one mirror plane which is perpendicular. Means one mirror perpendicular to A1, another mirror perpendicular to A2, another mirror perpendicular to A3. These three mirror planes are perpendicular to the crystallographic axis. The second position M represents perpendicular mirror planes to the crystallographic axis. Now, if we will take this mirror plane perpendicular to the crystallographic axis, they will be parallel to the diagonals. For hexagon, let's say this is a hexagon, this is one example of hexagon. In this hexagon, if we'll take one crystallographic axis, this is the crystallographic axis A2, right to left crystallographic axis. If we'll take this crystallographic axis, perpendicular to it will be a diagonal. This is a diagonal. This is not crystallographic axis, right? This is connecting the edges. This is connecting the edges. So it is a diagonal axis, but A2 is a crystallographic axis. If you take one mirror plane which is perpendicular to the crystallographic axis, it will be a diagonal mirror plane, or that mirror plane will pass through the edge diagonal. Similarly, if we will take perpendicular to diagonal, it will be parallel to crystallographic axis. Okay. So in this case, the mirror planes, they are perpendicular to the crystallographic axis, and that's why they are parallel to the diagonal axis. This M is present in the position of crystallographic axis, but as I told, first one is the C axis, second one is the horizontal crystallographic axis, A1, A2, A3. But still this M is perpendicular to the crystallographic axis and parallel to the edge diagonals. You can see the image or the figure in your book, then you will realize it. Okay, we'll also come to it later when we'll teach 32 classes in details. In these classes I will teach individually, so in that time we'll discuss again. I hope everybody understood. The conclusion of this part is M is always a perpendicular mirror. M is never a parallel mirror. M is always perpendicular mirror. Whether it is M or it is by M, it is always perpendicular mirror. Then why we write by M? That is also a question. You should ask why we write by M. What is the need of by M? Suppose as now I told 6M2. That means in one position we are having 6-fold, one position we are having mirror plane, one position we are having 2-fold axis. Suppose we will talk about, like here I told 4mm. This example I told 4mm. One 4-fold axis, one mirror plane and axial mirror plane and diagonal mirror. Now if the axes are also having 2-fold symmetry, let's say this horizontal axis, they are also having 2-fold symmetry. For example, if they are having 2-fold symmetry. Now where the 2-fold we will write? Where will we write the 2-fold? These are for the crystallographic axis A2 and A1, but in the position of A1 and A2 we are having one mirror plane also. So in place of A1 and A2 means the horizontal crystallographic axis, the first position is C axis. The second position is crystallographic axis A1 equal to A2. So for this two crystallographic axis, we have mirror plane also, we have 2-fold rotation also. And where we will write both of them? Can we write like this 4 2m m? Can we write like this? No. So in this case we have to write 4 2 by m. That means A1 and A2 both of them are having 2-fold rotation also and perpendicular mirror also. Similarly 4 2 by m 2 by m. We have this class 4 by m 2 by m 2 by m in tetragonal normal class. So this C axis 4-fold and a mirror plane perpendicular to it. A1 A2 2-fold and mirror planes perpendicular to it. Diagonal axis 2-fold and mirror planes perpendicular to it. Okay. So to represent two symmetry elements, axis of symmetry element which is the 2-fold rotation symmetry element and reflection symmetry element which is the mirror plane, to represent two different symmetry elements or a single position, whether it is the position of crystallographic axis or it is the position of diagonal axis. If there is two different elements, to represent that we are using this symbol by, means 2 by m we are writing. If there is no 2-fold axis, we will write m. If there is 2-fold axis and mirror, then we will write 2 by m. But it doesn't matter whether it is m alone or by M. M means always perpendicular.